Today, let us see how to do a bumpless transfer by using a analog circuit. What is bumpless transfer? Bumpless transfer is transfer from manual mode to auto mode of a PID controller or any controller of a PID controller. What is manual mode? Manual mode means open loop to closed loop. Auto mode means closed loop. Transferring from manual open loop to closed loop is called bumpless transfer. For that, three conditions has to be met. One is the process must be at steady state. Second condition is set point must be equal to PV. Third condition is proper tuning parameters must be entered. Tuning parameters of PID controller must be correct. So these are the three conditions we have to meet before doing the transfer from manual to auto. Why this is required? Because the controller itself cannot start from scratch. The controller cannot start from zero. We have to bring the process to nominal operating point. We have to bring the process to nominal operating point. Then we have to transfer from manual mode to auto mode. That is called transferring from manual mode to auto mode is called bumpless transfer. For that, the bias is required. To understand the bias, let us assume that set point equal to 50%. Controller is giving 50% output. Therefore, the valve is opening 50% because controller gives 50% output. Therefore, let us assume all ideal cases, the process is set to 50% level, 50%. Therefore, the transmitter, feedback transmitter, transmits process variable as 50%. Now, let us assume that it is in open loop. Let us assume that now the process is in open loop. If you close this, then only it is closed loop. That is called bumpless transfer. Now it is in open loop. The set point is 50%. The controller output in manual mode, it gives 50%. That's why the valve is opened for 50%. Therefore, the process is at 50%. Now, set point equal to PV. The process is settled at 50%. Therefore, process is at steady state. First condition is satisfied. Second condition also satisfied. Let us assume that appropriate tuning parameters were entered. That's why third condition also satisfied. Now, we can transfer from manual mode to auto mode. That is, we have to close the switch. If you close the switch, feedback will come. Therefore, the controller output becomes M of t equal to Kc multiplied by E of t plus Kc by Ti integral of E of t. Controller output. But the feedback is 50%. Set point is 50%. Therefore, error equal to 0. If you give 0 here, error equal to 0. Here also error equal to 0 means M of t equal to 0. Analytical controller output is 0. But what is at present value of controller? 50%. That's why the process is at 50%. That value has to be maintained at 50%. In auto mode also, that is called bias. This bias value, how we approached in manual mode, we adjust the controller valve, controller output, and hence the valve is adjusted so that the process is at 50%. That is manual mode output. Manual mode output. That should be added in closed loop also. That's why if you transfer from manual mode to auto mode, the controller output should not change. That should be taken as the bias value, additional value. For that, we need a circuit. That circuit today, let us see. Let us consider an operational amplifier based circuit. We are going to use a PI controller. Here, integral mode alone, we are going to tell the P mode is parallel with that. Sorry, P mode will be in parallel with that. That we are not going to mention here. Only I mode we are going to see. That I mode you need a capacitor. That is CI in series with a variable resistor, so that you can adjust the TI. By adjusting RI, you can adjust TI. In addition, one more capacitor is there that will charge during manual mode. That is bias value will be stored. For bias value, this capacitor is there. This is for operation during auto mode. Auto mode. For TI, this is for manual mode. This capacitor is for manual. Now, we are going to have a two-way, 4-pole two-way switch. Initially, it is at manual mode. 4-pole two-way. 4-pole two-way switch. It is simultaneously work. They are all connected together mechanically. If you operate up and down, all can be transferred from manual mode to auto mode simultaneously. This is 4-pole two-way switch. In that, this capacitor is connected. Initially it is in manual mode or manual. It is connected to a power supply plus 12 volt and minus 12 volt. This is decrement. This is increment. If you press this, the capacitor will charge. This is as minus, this is as plus. That's why the output will be increasing. If you press this decrement push button, the capacitor will charge this as plus and this as minus. That's why there will be a decrement. So increment, decrement can be given so that the controller output manually adjusted for 50% open. We have seen the previous slide that we are going to open 50%. So 50% output is required, that is adjusted by this increment, decrement. So in manual, this should be in this should be in negative feedback. Negative feedback. This is connected to positive and this is connected to negative. This capacitor also connected to inverting terminal. Yes, it is connected to inverting terminal also. Now it is in inverting terminal. This is input resistance, feedback capacitor. That's why it acts as the integrator. Integrator, that is to adjust the bias. We can adjust. So it is in manual. This positive terminal is under ground. This is under ground. Yes, this is under ground. This circuit can be drawn like this. This plus terminal is grounded. This negative terminal. This is resistor Rm and one capacitor Cm. This is inverting. This is this way. The plus 12 or minus 12 will be connected to increment this output. Output can be varied. This is in manual. Here we are giving that error signal that is not utilized now because it is in manual. These two are connected together. And this is connected here. Auto mode, if you transfer to auto mode, what happens to the circuit is will draw here. The circuit becomes, if you transfer from manual mode to auto mode, this capacitor, feedback capacitor, Cm is grounded. This end is grounded. Here, this end is grounded. Positive terminal is given E of T. And negative terminal is connected to the capacitor Ci. That's all. This is happening. This is happening. This is in auto. If you transfer the switch between these two, the circuit is switching between this and this. But in manual mode, we are charging this Cm to 50%. This Ci also charged to 50% because the output here is 50%. It is this capacitor is connected to the ground through this resistor. That's why this is also in 50%. But once you transfer from manual mode to auto mode, this capacitor, no input. This is just one end is connected to output, other end is connected to ground. That's why Ci is into picture, but already this is charged to 50%. This is also in 50%. That's why if you transfer from manual mode to auto mode, and that time the error equal to 0, no input to the integrator, but the controller output will be 50%, will be maintained. That's why the circuit is called Bumpless Transfer Circuit, because it doesn't give any variation in the output. Bumpless. Bump means variation. There is no bumpless. There is no bump in the output. it gives a bumpless transfer. Bumpless transfer. Smooth transfer. We can say like that. It gives a smooth transfer from manual mode to auto mode. This is for analog circuit. If you see digital, nowadays they are using microcontrollers. Microcontrollers for PID controller. Inside we have microcontroller. In the microcontroller, how to write a program for a PID controller, you will do in the lab. But anyhow, let us see the skeleton of that program. While an infinite loop will be there, that again and again will be executed. It will read the PV. It will read the PV, compare with set point, generate error. This will be done continuously. Compare with set point, generate error. But there are two modes. One is called a manual mode. Manual mode equal to true means this part will be executed. This part will be executed. Auto mode true, auto mode equal to true means the second part will be this mode, this part will be executed. That's all. Here, if it is manual mode means bias equal to increment or decrement. We have to do a logic so that the output, suppose it is a 8-bit DAC means the value will be varied between 0 to 35. 16-bit means it will be varied between 64,000 values. 0 to 64,000 values will be varied for this bias. For that algorithm will be there. Therefore, the controller output M of t equal to bias. That's all. In manual mode, this part will be executed. In auto mode, we have to calculate based on the error. Already error is calculated. So M of t equal to Kc multiplied by E of t plus microcontroller. That's why we cannot do the integration. That's why we have to do integration has to be approximated to summation. That is sampling period t multiplied by sum of E of k. Sum of E of k. Integration is replaced by sum of E of k. That you will see later. Plus whatever the value before transferring from manual mode to auto mode, the bias value we gave, that also will be added. The E of k is 0 initially because no error. That's why this is 0. This part also 0. That's why bias alone will come out. After these two loops, finally, the DAC equal to digital to analog converter is equal to M of t. That's all. This is the skeleton of the program for microcontroller. So we can simply transfer from manual mode to auto mode means automatically bias value will be coming as output.